NENOMATICA, where mathematics meets YouTube excellence. Let's take a look at our comprehensive course on quadratic expressions. This course covers everything from basic definitions to advanced applications of quadratics. Our course is divided into 26 comprehensive chapters that build systematically from introductory concepts to advanced applications. Let's examine the topics we'll cover. We begin with an introduction to quadratic equations, learning their standard form and basic properties. Next, we explore solving incomplete quadratic equations, which are equations missing either the linear or constant term. We then learn solving quadratics by factoring, which works well when the equation has nice factors, followed by the completing the square method, which is essential for deriving the quadratic formula. Speaking of which, the quadratic formula gives us a direct way to find solutions for any quadratic equation. We also explore an alternative quadratic formula that can be more convenient in certain situations. For a different perspective, we study geometric methods for solving quadratic equations, visualizing solutions on coordinate planes. Then we focus on practical problem solving with quadratics in real-world contexts. We explore the important relationships between coefficients and roots, followed by symmetric expressions in terms of the roots. In more advanced topics, we tackle systems of quadratic equations, special results related to coefficients, and how to form a quadratic equation when you know both roots. Moving forward, we learn how to form a quadratic equation when only one root is known, and determining two numbers from their sum and product, a key skill in factoring. We explore techniques for deriving a new quadratic equation from a given one, forming new equations in special cases, and the conditions for two quadratic equations to share a common root. Our analysis continues with methods for analyzing and solving quadratic equations and sign analysis of quadratic expressions. We also cover quadratic inequalities in one variable and comparing numbers with the roots of a quadratic equation. Practical skills include factoring quadratic trinomials and transforming certain equations into quadratic form, which lets us solve equations that aren't initially quadratic. Finally, we explore the graph of a quadratic function, learning about parabolas and their properties and zeros, roots of a quadratic function, which connects algebra with geometry. This comprehensive course on quadratic expressions covers all essential aspects, from basic definitions to advanced applications. By mastering these concepts, you'll build a strong foundation in algebra that will serve you well in more advanced mathematics courses. Thank you for reviewing this course summary on quadratic expressions. We hope you'll join us for this mathematical journey. Welcome to our math lesson on quadratic equations. Today, we'll learn about the definition of quadratic equations and how to identify them. Let's start with the definition. The general form of any quadratic equation is as follows: ax squared plus bx plus c equals 0. In this equation, a, b, and c are real numbers, and x is the variable with the highest power of 2. It's important to note that it cannot be 0, because if it is 0, the equation would no longer be quadratic, but would reduce to a linear equation. Let's look at an example. Determine if the following equation is a quadratic equation. Open parenthesis 3x minus 1 close parenthesis times open parenthesis x plus 2 close parenthesis equals 6. Let's solve this step by step based on the algorithm shown. Step 1. We'll expand the left side of the equation. This gives us 3x squared plus 6x minus x minus 2 equals 6. Step 2. Let's combine like terms on the left side. 6x minus x gives us 5x. So we have 3x squared plus 5x minus 2 equals 6. Step 3. Now, let's move all terms to one side of the equation by subtracting 6 from both sides. This gives us 3x squared plus 5x minus 2 minus 6 equals 0, which simplifies to 3x squared plus 5x minus 8 equals 0. After simplification, the equation takes the form 3x squared plus 5x minus 8 equals 0. Looking at this equation, we can identify that it equals 3, b equals 5, and c equals negative 8. Since it is not equal to 0, it is 3, this is indeed a quadratic equation. Let's summarize what we've learned. A quadratic equation has the general form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and it is not 0. To identify if an equation is quadratic, we need to rearrange it into the standard form and check if the coefficient of x squared is non-zero. We're going to learn how to determine whether an equation is a quadratic equation or not. Let's look at an example. We need to determine if the following equation is a quadratic equation. To determine if this is a quadratic equation, we need to simplify and rearrange it into standard form. Let's start by expanding the left side using the distributive property. The expression 2x plus 1 times x minus 1 becomes 2x squared minus 2x plus x minus 1. Next, let's combine like terms on the left side. Negative 2x plus x equals negative x. So our equation becomes 2x squared minus x minus 1 equals 2x squared plus 3. Now, let's move all terms to one side of the equation. We'll subtract 2x squared from both sides and move all terms to the left side. Let's simplify this expression. 2x squared minus 2x squared equals 0, and negative 1 minus 3 equals negative 4. So our equation becomes negative x minus 4 equals 0, or written differently, negative x minus 4 equals 0. After simplification, our equation has been reduced to the form negative x minus 4 equals 0. Let's rearrange this in standard form. The standard form of a quadratic equation is ax squared plus bx plus c equals 0, where is not equal to 0. In our simplified equation, there is no x squared term, which means this is a first-degree equation or a linear equation, not a quadratic equation. Let's summarize what we've learned. To determine if an equation is quadratic, we need to simplify it to standard form. If the highest power of the variable is 2, it's a quadratic equation. If the highest power is 1, it's a linear equation. In this case, our equation simplified to negative x minus 4 equals 0, which is a linear equation. Before we dive into specific examples, let's remind ourselves what a quadratic equation is. A quadratic equation has the general form ax squared plus bx plus c equals 0, where a, b, and c are constants, and is not equal to 0. To check if a value is a solution to a quadratic equation, we substitute the value into the equation and verify that both sides are equal. Let's start with our first example. We have the equation x squared minus 9 equals 0, and we're given that x equals 3. Let's check if x equals 3 is indeed a solution to this quadratic equation. Step 1. We substitute x equals 3 into our equation x squared minus 9. When we substitute, we get 3 squared minus 9, which equals 9 minus 9, which equals 0. So our equation becomes 0 equals 0, which is true. This confirms that x equals 3 is indeed a solution to the quadratic equation x squared is indeed a solution to the quadratic equation x squared minus 9 equals 0. Now, let's tackle a slightly more complex example. In this example, we have the equation t squared plus 3t minus 10 equals 4 plus 8t, and we're told that t equals 7. Let's verify if t equals 7 is a solution. Let's substitute t equals 7 into both sides of the equation. For the left side, we have t squared plus 3t minus 10, which gives us 7 squared plus 3 times 7 minus 10. This equals 49 plus 21 minus 10, which simplifies to 60. Now for the right side, we have 4 plus 8t, which gives us 4 plus 8 times 7. This equals 4 plus 56, which also simplifies to 60. Since both sides equal 60, the equation is satisfied when t equals 7, confirming that it is indeed a solution. Now, let's pause for a quick challenge. Try to verify on your own if x equals 2. Pause for a quick challenge. Try to verify on your own if x equals 2 is a solution to the quadratic equation x squared minus 4x plus 4 equals 0. Take a moment to work through this. Let's check. When we substitute x equals 2, we get 2 squared minus 4 times 2 plus 4, which equals 4 minus 8 plus 4, which equals 0. So x equals 2 is indeed a solution. Let's summarize what we've learned. A quadratic equation has the form ax squared plus bx plus c equals 0. To check if a value is a solution, we substitute it into the equation and verify that both sides are equal. In our examples, we confirmed that x equals 3 is a solution to x squared minus 9 equals 0, and t equals 7 is a solution to t squared plus 3t minus 10 equals 4 plus 8t. Consider the quadratic equation x squared plus x minus 1 equals 0 with roots alpha and beta. We are given that alpha to the 6th power plus beta to the 6th power equals 18, and alpha to the 7th power plus beta to the 7th power equals negative 29. Our task is to find the value of alpha to the 8th power plus beta to the 8th power. Our strategy for solving this problem will be to use the properties of the roots of a quadratic equation. Since alpha and beta are roots of the quadratic equation x squared plus x minus 1 equals 0, we know that both alpha and beta must satisfy this equation. This means alpha squared plus alpha minus 1 equals 0, and beta squared plus beta minus 1 equals 0. Now comes the clever part. We'll multiply the first equation by alpha to the 6th power and the second equation by beta to the 6th power. When we multiply the first equation by alpha to the 6th power, we get alpha to the 8th power plus alpha to the 7th power minus alpha to the 6th power equals 0. Similarly, when we multiply the second equation by beta to the 6th power, we get beta to the 8th power plus beta to the 7th power minus beta to the 6th power equals 0. Now, let's add these two equations together. When we add them, we get alpha to the 8th power plus beta to the 8th power plus alpha to the 7th power plus beta to the 7th power minus alpha to the 6th power minus beta to the 6th power equals 0. Let's rearrange this to isolate what we're looking for. Alpha to the 8th power plus beta to the 8th power equals minus the quantity alpha to the 7th power plus beta to the 7th power plus the quantity alpha to the 6th power plus beta to the 6th power. Now, we can substitute the values we were given. We know that alpha to the 7th power plus beta to the 7th power equals negative 29, and alpha to the 6th power plus beta to the 6th power equals 18. So, alpha to the 8th power plus beta to the 8th power equals negative of negative 29, which is positive 29, plus 18, which gives us 47. Therefore, alpha to the 8th power plus beta to the 8th power equals 47. Let's highlight our answer. Let's summarize what we've learned in this example. We started with a quadratic equation and information about certain powers of its roots. We used the fact that the roots satisfy the original equation and multiplied by appropriate powers to create new equations. By adding these equations and substituting known values, we found that alpha to the 8th power plus beta to the 8th power equals 47. This technique of manipulating powers of roots can be applied to many similar problems in algebra. Today we're going to solve a quadratic equation using substitution. Let's look at our example. Consider the quadratic equation x squared minus 5x minus 8 equals 0. If alpha is a root of the above equation, find the value of the expression alpha minus 5 times alpha minus 2 times alpha plus 4. Let's first understand the problem. We're told that alpha is a root of the equation x squared minus 5x minus 8 equals 0. This means when we substitute x equals alpha into the equation is satisfied. Step 1. Let's substitute x equals alpha into the equation. Step 2. Now, we need to rearrange this equation to isolate alpha times alpha minus 5. Step 3. From this, we can derive alpha minus 5 equals 8 over alpha. Step 4. Now, let's evaluate the expression that we need to find, which is alpha minus 5 times alpha minus 2 times minus 5 times alpha minus 2 times alpha plus 4. Step 5. Let's expand alpha minus 2 times alpha plus 4. Step 6. We can now continue our calculation. Step 7. We know that alpha squared equals 5 alpha plus 8 from our original equation. Let's substitute that. Therefore, the value of the expression alpha minus 5 times alpha minus 2 times alpha plus 4 is 56. Let's summarize what we've done. This problem demonstrated how to work with roots of quadratic equations and how to substitute. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.